cladograms are diagrams that show you the relationships between a group of organisms. This is what they look like. Sorry, this is kind of fuzzy. But you have sharks, fish, amphibians, so frogs, primates, those are your apes, rodents and rabbits and things, crocodiles, and birds. This shows you where the traits evolve. So this says bony skeleton. So anything before this point does not have a bony skeleton. So sharks do not have a bony skeleton. They are made of cartilage. Then the evolution of bony skeleton happened, and everything from that point on is going to have a bony skeleton. Fish have bones, frogs, apes, humans, rabbits, crocodiles, and birds. All right? Then we get all the way up here and we see the evolution of hair. So nothing from this point down has hair. It was only evolved right here in the timeline, and so everything from this point over is going to have hair. All right? Now, if hair was here, or if hair was here, that would mean everything from this point forward. But since hair evolved here, it's everything from this point forward. All right? And then here's eggs with shells. So this is where shells evolved. Everything from this point on gives birth to things in shells. Cladograms are diagrams that show you the evolutionary relationships among a group of organisms. It's based on phylogeny. They're physical genetic similarities. The presence of hair or the presence of bones. You get hair and bones based on your genetic code. So if that's similar, we're going to group you together. Biologists group organisms that represent their lines of evolutionary descent, not just physical similarities. So it's not just how they look. It has to be based on what their body is doing, what it looks like on a genetic level. All right, so this is what a cladogram looks like once it's done. This is what a cladogram looks like before you do it. All right, so I see that everything has a vertebrae. All right, everything on this list, all these animals have a spinal cord. So we're not talking about the other phylum of animals, ones that don't have that. We're just talking about the ones that do. So sharks have that, but no bones, they don't have four limbs, no amniotic egg. That means egg with water in it. They don't have hair, and they don't lay eggs with shells. Fish, so that's where this trait started, and everything from that point on has it. Fish are the first ones to evolve this trait, then everything else has it. Amphibians are the first thing to have four limbs. From that point on, everything else has it. So we know that all of these things evolved from these lower level things. Now, I'm not saying primates came from fish. I'm just saying that fish came before primates because primates are more evolved. They have more features. So the less features you have, the more ancient you are. The more features you have, the more evolved you are. So let's build one. You're going to have to draw a cladogram and tell me where these traits show up. So the first thing we have is a shark. Then we have fish. Then we have amphibians, so I'm just going to write frog. Okay. Then we have primates. Then we have rodents. These are things like mice, rabbits, rats. We have reptiles. Things like lizards, alligators, crocodiles, and then aves are birds. Okay? All right. So now, at this point, this is where we evolved a vertebrae. So whatever organism came before us, nobody had vertebrae. Then we had a vertebrae, and now we have sharks. Okay? Then at this point, this is where bones evolved. And so now everything from this point on is going to have bones, including fish, frogs, primates, rodents, reptiles, and birds. Okay? Then we evolved 4 limbs. And so everything from this point on has 4 limbs. Then we evolved an amniotic egg. An egg that has water in it. Anything down here, these guys are laying their eggs in the water. So they don't need to have water inside their eggs. You only need to have water inside your egg if you're laying your eggs on land or somewhere where there's not water. Okay, so at this point, from this point on, everything has amniotic eggs. We have an internal amniotic sac. That's the sac that the baby floats around in before it's born. And the mother's water breaks. Okay? Then we have the evolution. Oh, wait. Of hair. Right? I know hair happened here somewhere after this because only primates and rodents on this chart had hair. These guys don't. So I know hair didn't happen here because that would mean everything else has hair, but it doesn't. So hair evolved right here. Then you have the evolution of eggs with shells. And everything from this point on is going to have eggs with shells. So what you're going to have to do is I'm going to give you your blank cladogram sheet, which is this one right here. And what you're going to have to do is you're going to have to look at these traits, and you'll see that there's some blank spaces. You're going to have to fill in what trait evolved at each letter. So for example, the worm is the only thing with a segmented body. All right, it doesn't have any other characteristics. So it's the most ancient thing. It was the most simple, the first to evolve. So I know that a segmented body evolved right here at point A. Okay, so if you have any questions with the cladograms, please email me. I can FaceTime you or Skype you or whatever. We can go on Zoom, whatever you need. But you're just going to have to fill these in. So these are going to be blank. Okay, and I'll say to you, here's letter A, here's letter B, C, D, E, and F. I will say what trait evolved at step B. And you know that sharks have vertebrae, so do fish, and so do everything else. But right here, bones must have evolved because fish and everything else have bones, but the shark does not. So this is where bones evolved. Those are your cladograms. Finally, we have dichotomous keys. What you're going to have to do is use this key to figure out what the name of that bird is. We use dichotomous keys in field guides a lot. If you go out into the woods and you're camping or hiking or on an expedition and you find a plant, you're hungry, you got to forage for berries, you're going to use your field guide to identify what those plants are to see if they're poisonous or not. So for example, I would find a plant and then I would look in my book, and my book would say, if it has fuzzy leaves, go to this page. If it has smooth leaves, go to this page. And so I go to the page it's supposed to be at, and then it'll say, if it has thorns, go to this page. If it doesn't have thorns, go to that page. So it takes you step by step to figure out what the species is. All right, so for example, we are going to name bird X, this one. So what you do is you start at step 1, you answer yes or no, and then you move on. So step 1, the beak, all right, the beak is relatively long and slender. Probably not. That one's long and slender. Okay, so no. The beak is stout and heavy? Yes. So I'm going to go to step 2. The bottom surface of the lower beak is flat. No, that's round. So no. The bottom surface of the lower beak is curved. Yes. So now I'm going to go to step 3. The lower edge of the upper beak has a distinct bend. No, that looks pretty flat to me. The lower edge of the upper beak is mostly flat. Yes. So I know that bird number 2 is a platyspizia. You have a dichotomous key worksheet that you're going to be working on, and it deals with leaves, not birds. So make sure you turn that in. It's due Friday. Your cladogram worksheet is due Friday, and your completed notes pack is due Friday. Thanks for watching, guys. Feedback is helpful. If you like this, we'll keep going with it. If you hate it, let me know, and I will figure something else out. Stay safe, stay healthy. I miss you. Bye.